Dimethylformamide is an organic compound with the formula 2NCOH. Commonly abbreviated as DMF, this colourless liquid is miscible with water and the majority of organic liquids. DMF is a common solvent for chemical reactions. Dimethylformamide is odorless, whereas technical grade or degraded samples often have a fishy smell due to impurity of dimethylamine. As its name indicates, it is a derivative of formamide, the amide of formic acid. Dimethylformamide is a polar aprotic solvent with a high boiling point. It facilitates reactions that follow polar mechanisms, such as SN2 reactions. Dimethylformamide can be synthesized from methyl formate and dimethylamine or by reaction of dimethylamine with carbon monoxide. Dimethylformamide is reactive towards strong bases such as sodium hydroxide or strong acids such as hydrochloric acid or sulfuric acid, and is hydrolyzed back into formic acid and dimethylamine, especially at elevated temperatures. Structure and properties: due to the contribution of the two major resonance structures of an amide, the bond order of the carbonyl C=O bond is reduced and that of the carbonyl-nitrogen bond is increased. Thus the infrared spectrum of DMF shows a lower C=O stretching frequency at 1675 µm than an unsubstituted C=O bond. Also, because of the partial double bond character, the rotation about the CN axis is slow at room temperature, making the two methyl groups inequivalent on the NMR time scale, giving rise to two singlets of 3 protons each at I2.97 and 2.88, instead of one singlet of 6 protons in the proton NMR spectrum. DMF is miscible with water in all proportions. The vapor pressure at 20 degrees Celsius is 3.5 hectopascals. A Henry's law constant of 7.47 A, 10^5 HPaAm3 per mole can be deduced from an experimentally determined equilibrium constant at 25 degrees Celsius. The partition coefficient log power is measured to a 0.85. Since the density of DMF is very similar to that of water, significant flotation or stratification in surface waters in case of accidental losses is not expected. Production: dimethylformamide is produced either via a catalyzed reaction of dimethylamine and carbon monoxide and methanol or via the reaction of methyl formate with dimethylamine. Applications: the primary use of dimethylformamide is as a solvent with low evaporation rate. DMF is used in the production of acrylic fibers and plastics. It is also used as a solvent in peptide coupling for pharmaceuticals, in the development and production of pesticides, and in the manufacture of adhesives, synthetic leathers, fibers, films, and surface coatings. It is used as a reagent in the Butylaldehyde synthesis and in the Vilsmeier-Helic reaction, another useful method of forming aldehydes. It is also a common catalyst used in the synthesis of acyl halides, in particular the synthesis of acyl chlorides from carboxylic acids using oxalyl or thionyl chloride. The catalytic mechanism entails reversible formation of an amidyl chloride. DMF penetrates most plastics and makes them swell. Because of this property, DMF is suitable for solid-phase peptide synthesis and is a component of paint strippers. DMF is used as a solvent to recover olefins such as 1,3-butadiene via extractive distillation. It is also used in the manufacturing of solvent dyes as an important raw material. It is consumed during reaction. Pure acetylene gas cannot be compressed and stored without the danger of explosion. Industrial acetylene gas is, therefore, dissolved in dimethylformamide and stored in metal cylinders or bottles. The casing is also filled with agamisen, which renders it safe to transport and use. Niche uses: as a common and cheap reagent, DMF has many uses in the research laboratory. DMF is effective at separating and suspending carbon nanotubes, and is recommended by the NIST for use in near-infrared spectroscopy of such. DMF can be utilized as a standard in proton NMR, allowing for a quantitative determination of an unknown compound. In the synthesis of organometallic compounds, it is used as a source of carbon monoxide ligands. DMF is a common solvent used in electrospinning. Safety: reactions including the use of sodium hydride in DMF as a solvent are somewhat hazardous. Exothermic decompositions have been reported at temperatures as low as 26 degrees Celsius. On a laboratory scale, any thermal runaway is quickly noticed and brought under control with an ice bath, and this remains a popular combination of reagents. On a pilot plant scale, on the other hand, several accidents have been reported. Toxicity: DMF has been linked to cancer in humans, and it is thought to cause birth defects. In some sectors of industry, women are banned from working with DMF. For many reactions, it can be replaced with dimethyl sulfoxide. Most manufacturers of DMF list life or chronic as a health hazard in their MSDS, since DMF is not readily disposed of by the body. According to IARC, DMF is a possible carcinogen, although EPA does not consider it a cancer risk. References. External links: International Chemical Safety Card 0457, NIOSH Pocket Guide to Chemical Hazards 0226, dimethylformamide usage on organic syntheses, Concise International Chemical Assessment Document 31, N dimethylformamide, Material Safety Data Sheet for DMF, DMF Chronic Toxicity Summary, dimethylformamide Technical Specs from BASF, PDF, DMF GHSMSDS from New Gentech.